Suppose we wish to find an approximate value of the sine of 36 degrees using the triangle shown. Notice that the side opposite the 36-degree angle has a length of 52.9. I don't know what the units are here. Let's call them inches. And the hypotenuse has a length of 90.0 inches, in which case we could say the sine of 36 degrees would be approximately 52.9 divided by 90.0. It's the whenever we're talking about the sine, it's always the side that's opposite our angle divided by the hypotenuse. So the sine of 36 degrees, according to this calculation, 52.9 divided by 90 is, well, each of those are to 3 significant digits, so I'm going to round this to 3 significant digits, and I'm going to call it 0.588. If we were to actually try to find sine of 36 degrees on the calculator, there actually are specialized keys on most calculators, or at least the calculators I recommend for this class. You can see this key right here. It says sin. That's actually sine. And if I type sine and then 36, this is in degrees by default, I believe. Yeah, I believe it's in degrees. So when I press enter, I get 0.5877778, or whatever. 0.588. If I round it off, it's approximately 0.588, and you can see it's the same value there. If we wanted to use this triangle to approximate the value of sine of 50 degrees, and let's round it to 3 decimal places, and then verify this on the calculator, well, we're saying that sine of 40 degrees, according to this, this is not usually how we find the sine of 40 degrees. Usually if we're finding the sine of 40 degrees, we don't need to do anything with the triangle here. What we would do is we type in the sine of 40 degrees and get 0.643, it looks like. So that's how we would actually find the sine of 40 degrees. However, if we're trying to use this particular triangle, oh, this is supposed to be the sine of 50 degrees. So let me do that one instead. Sine of 50 is 0.766. So that's what the sine of 50 degrees should be. If I was actually to try to calculate the sine of 50 degrees using this particular triangle, I would want to take the side that's opposite my 50-degree angles, that's this side right here, and divide it by the length of the hypotenuse. This would be 47.5 divided by 62.0. So sine of 50 degrees, this is an alternate way to calculate it. Well, less accurate and more effort, but that's why we're doing it, right? 0.766. And you can see we get approximately the same number. Not quite the exact same number. The sine of 50 degrees, if I show more accuracy on here, you can see there's 766044443, whatever. For this one, if I plug that in there, it was should have been 00, whatever. So it's clearly not exactly the same number, but that's a result of the 62.0 and the 47.5. Probably those numbers are not exact. Well, yeah, they're definitely not exact, and that's why this ratio doesn't come out to be exactly the same as what my calculator says the sine is.